To do this question, we have to make an assumption. I wrote it down underneath the diagram there. We're going to assume that the water lands at the same elevation as it was shot from. And that's the only way we're allowed to use the formula for the level horizontal range. Okay, that's the situation when that formula applies. And we're going to use that formula and we're going to solve for theta, the angle. They're asking us for the angle. So I'll do some rearranging here. I'll do it in a couple of steps. First, moving the v squared over as well as the g. Leaving the sine 2 theta on the right side. Now to get rid of the sine, we're going to do sine inverse. And then we're going to divide by 2 or multiply by 1/2. I will put the values in here. Range is 2. G is 9.8. Velocity squared is 6.8 squared, or speed squared is 6.8 squared. Now this will result in 2 answers. So you have to remember your trigonometry here. I'm first going to type the inverse sine in my calculator of 2 times 9.8 over 6.8 squared, resulting in 25 degrees. However, there's a second answer. If you remember your trigonometry and the 4 quadrants, maybe your teacher used a CAST acronym. One answer of 25 degrees occurs in the all quadrant. There's 25 degrees. And a second answer occurs in the S quadrant because we have a positive value for sine. So we take that 25 degree reference angle, we draw it 25 degrees away from the horizontal axis in the S quadrant. And we ask ourselves, if I start at the positive x-axis and then go all the way around to my second arm there, how many degrees is that? It's going to end up being 180 minus 25 degrees. So the other answer is 180 minus 25 degrees, which is 155 degrees. Okay, so I'm going to highlight it in yellow. Sine inverse of something this has 2 answers, or 2 values. Okay, 25 as well as 155. And then I'm going to apply the half there. So half times 25 is 12.5, which rounds to 13 when I'm doing significant digits. And half of 155 is going to be 78, or, well, they should add up to 90, so I'm going to go with 77. I should have been a bit more careful in terms of not rounding too soon, but I think it ends up being 13 and 77 degrees. So the diagram there, the way I drew it, that could be one trajectory of the water, maybe the 77 degree trajectory. But if we were to fire the water at 13 degrees at the same speed, it should hit the ground at the same spot.